In the last video, we looked at the difference between containers and virtual machines. We also introduced the container runtime, a component that works with operating system kernels to quote-unquote create containers. Let's briefly talk about what creating containers actually means. A container is composed of two things, a Linux namespace and a Linux control group. The diagram below describes these components in more detail. Let's start with namespaces. Namespaces are a Linux kernel feature that provides the ability to expose different quote-unquote views of your system to applications running within it. This way, you can have an application think it's running as the, say, root superuser with access to an entire file system and all sorts of hardware when it's actually running as user 154678 with access to a single folder. Today's Linux kernels provide 8 namespaces. The ability to view and create users through the user ns namespace, access to file systems through the mount namespace, network communication abilities through the net namespace, interprocess communication through the IPC namespace, the ability to change time through the time namespace, process ID management through the PID namespace or PID, the ability to create and list control groups through the cgroup namespace, and the ability to create host and domain names through the UTS namespace. One thing to note, due to technical limitations, Docker containers use every namespace but the time namespace. This just means you can't change the time in a Docker container. Control groups, another Linux kernel feature, build on this by providing the ability to restrict how much hardware each process can use. Docker uses control groups for a few things. First, it uses control groups to monitor and restrict CPU usage, or the amount of CPU time each container can take up. Docker also uses control groups to monitor and restrict network and disk bandwidth. And more commonly, Docker uses control groups to monitor and restrict memory consumption. This makes it easy to prevent busier or larger containers from eating up all of the system's resources and slowing other containers down without having to carve up significant amounts of memory like virtual machines do. Note that you cannot use control groups to assign disk quotas to containers. Fortunately, there are many quote-unquote container-native storage solutions that allow you to do this. Control groups and namespaces are a very different and much lighter weight approach to isolation than virtualizing entire pieces of hardware like virtual machines do. However, these features come with two important caveats. First, because control groups and namespaces are Linux-only features, this means that Docker technically only runs natively on Linux, and some newer versions of Windows as well. Second, and more importantly, containers can run on anything, but their images are tied to the kernel they were created from. Containers created from container images configured for Linux kernels can only run on Linux. Conversely, containers created from container images configured for Windows can only run on Windows. Fortunately, there are established workarounds for these limitations. We'll introduce them in the next video.